I want to take a couple minutes to talk about homework format for Engineering 305 for my section. And that is, I think you've been trained, in 202 uses this, even Engineering 101 uses this, that we recognize as faculty that there's a story that you're telling. And I think you need to start thinking about your homework as telling that story. In some ways we can take shortcuts and we can do, but that process of telling a story, or that process of solving an engineering problem, is fairly consistent. And I think in order to do a good job, these are the parts of the story that should be really in every problem. And that is a problem statement. What are we trying to find? What are we trying to do? What are the givens? There should be a sketch so that we understand the physical situation. And maybe that's my bias as a mechanical engineer. Maybe if you're an electrical, there doesn't need to be a sketch. I don't know. Maybe, but there should be some picture, I think, because a picture is so valuable in explaining the situation. And then I jump to observed relationships. What are the equations that are going to help us figure out the next step or the next thing? What assumptions are we going to use? And sometimes assumptions go above the observed relationships, because sometimes the assumptions allow us to pick an observed relationship. And sometimes our observed relationship is simplified with our assumptions. So those things change and depend. And then I think we have to work towards a resolution, where we are doing algebra, where we're taking that observed relationship and we're converting it down so that we can come up to, this is what I'm looking for, and it equals something with units, with everything else. And lastly, there's an answer that is provided that tells us what we need to know. For a textbook problem, that usually is an answer that, for a textbook question, that answer is usually straightforward. Force is equal to 15 newtons, and we're going to put a box around that, but maybe not. So I do go through in this document and amplify some of these ideas, so that you can see those. But this is what you've been trained to do. And I want you to think about this as telling a story. The problem statement, that's setting up the conflict. Givens is providing some of the backstory that's necessary to give the characters depth. Sketch gives us the environment, the environment that the story is taking place in. Observed relationships, maybe some of the constraints and the other things that go in. But then we make assumptions, and that as the story progresses a certain way, the story gets resolved. And that may be part of the falling action. Really, once we've got the assumptions and the governing equation, then things start to drop off. So it's hard to put absolutes on this, but numbers should almost always have units. There may be things like emissivity, which don't have units, or shape factors, which don't have units. Some of the straight math problems will not have units, but engineering problems almost always have units. So, and keeping track of them throughout your problem is very important. So I think if you use this methodology, it will give you the best chance of communicating a correct solution to an engineering problem, but it also sets up a way of thinking that allows you to solve problems that you don't understand, because it allows you to lay out in a clear way. It allows you to lay out in a clear way what is going on and what do I know and what new things can I figure out. So I've got a couple more suggestions, and that is, in addition to just knowing the format, sometimes it helps to have a draft that you've just worked through. Here, this is what I know. This is what I can do. And then rewriting that into a solution so that it is neat and organized, and these 7 different areas are well laid out. You will hear it in the videos. Use a pencil. Simple mistakes can be erased and redone without creating a lot of sloppiness. I'm doing the homework solutions this semester in pen, but that's because you really can't see gray pencil on a white background very well. I don't have the lighting and the tools for that to go very well. But um, and again, I'll say too, neatness is professionalism, is part of professionalism. So you really want to have some polish to this. And a straight edge should probably be used to help you in sketches, to help you out with neatness. So it doesn't require anything special. I'm going to say, sitting next to my desk, I've been using a dead Starbucks card to help me with some of the sketches that I'm doing. So um, there will be times which we'll grade the homework for those 7 areas, and we will look at making sure that you're doing those points. So I, this isn't anything new. You've seen it in 101, you've seen it in 202. You will see this from many different institutions. And in fact, this document that I put together is based on documents that came from MIT, Old Dominion, and University of Utah, as well as textbooks from James Earl and David Ullman. Ullman is one of the great thinkers on engineering problem solving. So nothing new here. I hope this uh, maybe helped explain some things, but will give you some guidance in how you should approach your homework. Take care.